Hey, thanks for watching. This is a class from the second annual HVACR Symposium from my friend Tony Gonzalez from Fieldpiece. He's going to talk about how to take better measurements and high quality measurements out in the field as an HVACR technician. Big thanks to Fieldpiece for being involved in the event and for sponsoring everything that we do at HVAC School. To find out more, go to fieldpiece.com. Hope you enjoy.
Today we're going to talk about HVACR wireless system troubleshooting, better and faster than ever. My name is Tony Gonzalez, and I'm the Technical Training Manager for Fieldpiece Instruments. And like I was saying prior to class begin, we're going to have a quick 50 minutes, so I'm just going to hop right into it. Many of you are already familiar with Fieldpiece as a brand, kind of what we do. We design and manufacture products specifically for the HVACR industry, not for anything else. And when we develop a product, there has to be a reason to develop the product. We would never come out with a me too product. If we're going to come out with something, it's because we have a way to make it help you do your job easier, faster, or better. Okay? So today we're going to talk a little bit about wireless system troubleshooting and how it helps you how it helps you in your business. So first let's start with the goal of any service company is to have happy customers, right? A happy customer will stay a customer, and a happy customer will bring in new customers. And that results in happy customers bring in revenue into the business. And a business that is bringing in revenue is a happy business, okay? So it all boils down to, at the end of the day, we want to have happy customers because that'll translate into a happy business. Now, what does that have to do with system troubleshooting? Well, first we need to understand what a high-quality measurement is. Okay? Now, we're going to talk a little bit about what it is and then why that's important. But first, you guys take measurements all the time on your jobs, constantly, dozens of times a day. And it's extremely important that you take good, high-quality measurements. So what does that mean? Number one, you kind of have to have an understanding of the issue that you're looking for in order to take a high-quality measurement. You know, you got to know, well, am I trying to find an airflow issue or a charge issue? Because if I'm looking for an airflow issue, I'm not going to be measuring pressures and temperatures at the outdoor unit. Okay? It seems obvious, but there's a process to this. Secondly, after we understand the issue, we need to understand what type of measurement we need to help us troubleshoot that issue. So if I suspect that there's low incoming voltage to a system, I'm not going to take an amperage reading. Okay? We have to match the measurement to the issue that we're looking for. Number three, we need to know the best location to take a measurement. Okay? If I'm taking a measurement because I suspect a refrigerant charge issue, and I want to take a subcooling reading because I have a TXV metering device, I'm not going to take pressures and temperatures on the suction line, right? So location is key. Also, well, that's enough on that for now. After that, we need to choose what is the appropriate tool for the application that we're on. Okay? There are different types of tools that could take the same measurement. So if I want to take an airflow measurement inside of a duct, I'm not going to use a vane anemometer. It's a pretty big hole. I'm going to have to get in there, and it's just not going to work. So choosing the right tool for the application, and finally the right time to take the measurement. Okay. Again, going back to the scenario of if I suspect low incoming voltage coming into my system, am I going to take a voltage measurement with the system off or on? On, right? If it's off, that's not the right time to take that measurement because it's not going to help me figure out what's going on. So when we're going through our jobs and we're taking measurements, let's just stop and pause and think, am I taking a high quality measurement? Do I understand what I'm looking for, what measurement I need, what tool I need to make that best? Is it in the right location, and am I taking it at the right time? And the reason that's important is because we talk to homeowners, we talk to customers. So let me walk you through this process. You have a homeowner that is explaining to you what the issue is. Okay? They're giving you information. As a technician, you are processing that information in your mind, and you're using your senses, your knowledge, and your tools to help troubleshoot that issue. Take a bunch of measurements and find out what's going on. After you have this data, you are processing that information in your mind, and you are communicating to your customer how their system is performing, where you suspect there are issues, and then that customer is making a decision based on the information that you're giving to them. And then they are spending money on that decision that they make based on the information that you gave them. Now, what happens in the scenario where a technician gives the homeowner incorrect or non-complete information based on not taking high-quality measurements? What happens? Not everyone at once. I can't focus on one. Absolutely. Absolutely. In the short term, you had the customer maybe make a decision to do some work. So in the short term, you got revenue. In the long run, that's not going to work because something else is going to go wrong with the system. Customer's not going to be happy and probably going to lose a customer. Okay? So the importance of taking a high-quality measurement helps keep happy customers. Okay? So if we look at it that way, we want to provide the homeowner with the most accurate information so they can make the best decision for them and they can be happy. Okay. So now that we've laid that foundation, let's talk a little bit about system troubleshooting. Because who doesn't love a flow chart, right? It's kind of half joke, guys. Come on. Let's loosen up a bit in here. So the way that I like to look at troubleshooting, at a very, very high level, it's pretty simple. At a high level. You have 4 steps. Step one, we need to understand the problem. Next, we need to find the problem. Third, we need to fix the problem. And fourth, though a lot of people don't think this step exists, we need to test system operation after we fix something. Okay? At a very high level, that's what system troubleshooting is. It's not that complicated. But if we break it down into its components, number one, how do we understand the problem? Well, we need to ask questions. We get on site, we talk with the homeowner, we talk with our customer, and we ask questions. We let the customer talk to us, and most importantly, we listen to what they're saying. Now, you have run across this many times. A homeowner is not going to innately know how to describe their issue in a way that's useful for you in your job. Simple example. You go on site, what seems to be the problem, Mr. Homeowner? My AC don't work. To them, that's what they're experiencing, right? So, as a technician, it's important to be able to know how to ask follow-up questions so we can get useful information out of our customers that's going to help us do our job faster and better. So something like, well, my AC system doesn't turn on. That's useful to us. You know, that gives us a little bit of guidance on where to start. Or, you know, my system turns on, but the air is not as cold as it used to be before. That's also useful. You know, that can help us know where to begin to troubleshoot. So understanding the problem is key, because if we don't understand the problem, we're going to waste a lot of time downstream in the troubleshooting process. So talking to the customer, listening, helping extract the data that's useful to you. Now this is where the magic happens, finding the problem. And this is probably where we spend the majority of our time in this flowchart. Finding the problem is what separates great technicians from average to poor technicians. A really good troubleshooter can find a problem faster and easier. And there's a couple ways that we do that. Based on the information that a customer gives to us, we might do some visual inspections, check a filter, check the condenser unit outside, maybe it's all dirty, check some duct work, see if there's any major pinches or anything like that. But a bunch of visual inspections are usually easy. And then at some point, we're probably going to have to start taking some measurements. Okay? And the way that we measure performance of an HVAC system comes in basically 3 categories: airflow, electrical, and refrigerant charge. We're basically looking at those 3 categories to determine how an air conditioning system is working. And based on what the issue is, it will help us know where to start on a particular job here. Okay? After and we'll get into this step more as part of our class today, but let's just finish out this flowchart here. After we found the problem, you tell me, is fixing it the relatively simple part compared to finding it? Depends on the repair, but it's not something that you kind of have to figure out. You know how to do it, but it just might take time, right? So we repair the problem or we replace the problem. And then finally, and sometimes overlooked, is test your system operation. We need to ensure and verify that the repair or the replace that we made actually solved the root cause of the problem. I know sometimes we got so many jobs to do in a day that we just got to get to all of them, that this might be overlooked sometimes because we're fairly confident that we found the problem and we fixed it. But it's extremely important in order to maintain a happy customer to confirm that what you did actually worked, and using wireless technology helps us do this a lot quicker than before. So it's not something we have to skip due to time. Okay. Let's do a little role play now. Are we on time? So, we have Mr. Technician, arrives on site, starts talking to a customer, and what he gleans from the customer in this time is, you know what? My air conditioning system doesn't turn on. Okay. So you as technicians, you hear that. Which one of these 3 performance criteria are you going to start in? Airflow, electrical, or refrigerant charge? Electrical. So what kind of measurements might we take based on the air conditioner doesn't turn on? Check voltage, okay? That's typically one of the most basic things, right? Maybe check some fuses, something like that. Yeah, continuity, things like that. Okay, so let's talk a little bit about electrical. So just a couple of basics when it comes to clamp meters. Many clamp meters are going to have auto-ranging capabilities. And what that means is, back in the old VOM days, when you measured voltage, there were a lot of different ranges on that dial, and you had to set the dial to the range that you anticipated your measurement was going to be in so that you can get a good reading. Now, the majority of clamp meters are going to have auto-ranging capability. So what that means is that when you connect your test leads to measure voltage, the meter might need a second to find the correct voltage that you're trying to measure, but then once it sets itself into that range, the reading is going to be instant, and it's going to be accurate if you have a good, accurate meter. Okay? So that's just something to keep in mind. Now, for extremely low voltage measurements, many of these clamp meters, like this one, has a manual ranging feature as well. So you can log in a range into a low voltage range and then take the measurement because you know the measurement that you're going to measure is low voltage, and in an instant, you get the reading there. Okay, there's a couple of helpful tips there. Now on amperage, on the back of a clamp meter clamp, you are typically going to see some arrows. What do those arrows mean? Does anybody know? Yeah. So typically what these arrows mean on the back of a clamp meter is to help you follow best practices on where to position a wire when you're taking a measurement to get an accurate clamp reading. So typically, you would want to put the wire in the center of the clamp to get the most accurate reading. However, one of the benefits of the Fieldpiece clamp meter is that the clamp was designed so that accuracy doesn't vary much no matter where you put the wire in the clamp. And that's particularly useful because you don't want to have to be holding your clamp meter and not moving it on the wire, surrounded by all these wires, so that you make sure you get it right in the middle, right? You want to clamp it, hang it, and just let it do its measurement, okay? So a couple of helpful tips when using a clamp meter. Now, we already talked about some of the measurements that we would do if we suspected that we had a problem of a system not turning on. So I want to talk a little bit about variable frequency drives. Now, at a very high level, what a variable frequency drive system, like a mini split, does is it's not always easy to get a high quality voltage and amperage measurement on those types of systems. Because what those systems do is they take an AC voltage signal coming in, they convert that AC signal into a DC signal, right? And then they convert it back into an AC signal, typically a modulated AC signal, before it's fed into a compressor and a fan so that those compressors and fans can vary their speed based on the load. Now what happens during that AC to DC to AC conversion is that a lot of electrical noise is generated in that voltage signal. And with a normal true RMS meter, you may not get an accurate voltage or current reading due to that noise that is generated in the signal. So you want to find a meter that has a low-pass filter built in for voltages and amperages, so that when you take those measurements, it'll filter out the noise of that signal and help you get a more accurate measurement on variable frequency drives. And when we're talking about picking the right tool for the job, variable frequency drives on the circuit boards have what kind of plugs? Molex plugs. And typically, the standard Tesla tip does not fit inside of those Molex plugs. Sometimes they do if you jam them in there really hard, right? But typically, they don't. We're going to develop a product that's going to help you do your job easier, faster, and better. And so they come included with the Molex Tesla tips so that you can easily got me twice already, bro. You're not getting me again. All right. You plop off the top. You insert your probe tip on both sides, typically, and then you can easily take your measurement on Molex plugs. Comes with them. You don't really have to, purchase anything separate. Okay, so the last thing I want to cover in terms of electrical to help maintain a happy customer and a happy business is a power consumption reading. So the JobLink power clamp meters have a switch position where it's labeled W, and that measures watts, kilowatts in real time. And it's a very simple measurement to take. All you need is to measure voltage and current at the same time. So I wanted to be able to do a little demo here for you guys, but it's not really conducive to the visual, so I'll just kind of act it out for you. Like a mime, but I'll be talking. So a good way to do it is use a couple alligator clips. You want to clamp it on to the incoming voltage at the outdoor unit, L1, L2. And then you take your clamp meter and you clamp it on either L1 or L2 wire. Doesn't really matter. And then the meter starts displaying to you kilowatts in real time. Now, what can you use that for? Well, you can use that for SEER. You could also use that for feedback that we got from the field is, you go to a site, maybe you have like a maintenance contract with customers, right? You arrive on site, first thing you do, take a power consumption reading. Document it down in your job link report, things like that, for before. Then you perform your maintenance. You clean some stuff, maybe you get the charge right, adjust airflow, all that stuff. You take a power measurement, power consumption reading afterwards, it's lowered. So now you can show your customer, this is what your system was consuming before I did my maintenance. This is what it's consuming now, and translate into energy cost savings for the customer. So that helps them. So that helps validate the work that you've done, making them happy, and keeping them as a customer. Okay. So any ways that your tools can help your customers be happy and generate revenue for your company is a good thing to have. Okay. So, and by the way, if there are any questions along the way, please feel free to raise your hand.
I was going to say any questions that people do ask, future questions.
Absolutely. So do you have one, or are you just telling me that?
No, I don't have any.
Okay, all right. Awesome, perfect. Okay, awesome.
What's the model on that lamp on? Is that a new version for watts?
They came out last year, so the beginning of 2020. So part number is SC680, and then there's a smaller version without lead storage and without swivel clamp. Actually, the swivel clamp is really cool. We thought it was a gimmick at first, but it's really convenient when you clamp onto a wire at a weird angle, and you can just rotate to be able to see your screen without having to like bend over and do all that stuff. So any little thing that helps you do your job better, that's what we think of. Yes, sir. Absolutely. On the side, inrush button, you put it on the amps feature, just press inrush, put it on the wire before you fire up the system, and it captures that peak amperage for you. Good question. If you have, yeah?
The 460 is the smaller one that doesn't have the swivel, right? That one's like 18 inches or something.
You mean height? I'm not sure. I've never measured it. 18? Nah, this is probably like a foot. I mean, I think of like an 18-inch burrito that I had like a while back, and it was a lot bigger than this thing. So I don't know. That was a bet type of thing. So don't ask me about that. I won, by the way, in case you were wondering. Yeah, I won. All right. Let me tell you. No, just kidding. Let me tell you about it. Okay. Okay, some more specific questions about the clamp meter. You can talk to me afterwards or at the demo time tomorrow. I'll have all the tools set up and go like that, but perfect. So we covered a little bit of the electrical side. Now let's do another little role play. Now we arrive on site, we talk to the customer, and the customer tells us, my system's on, but the air is just not as cold as it used to be. Okay, so at that point, we're probably not going to be checking continuities first. I mean, we could, but we're probably not going to do that. We're probably going to look more into something like airflow and refrigerant charge. But I like to start with the non-invasive techniques first and see if I can figure out the problem. So let's go to airflow. Now, airflow is oftentimes overlooked. But with the right technology, with the right tools, there are some very simple yet powerful informative measurements that you can take to help you understand the performance of the system. So when we're talking about measuring conditions of air, we're talking about measuring first temperatures and humidity. So having a good psychrometer to measure temperatures and humidity is vital to have. And we can perform a couple different tests here. We can do a delta T test we can do a target evaporator exit temperature test at the same time, and we have to determine the best location to take the measurements, either in duct or at a register. Now, typically in the real world, what is going to determine where I take these measurements? What do you guys typically? Accessibility, right? Right. Ideally, it would be great to get in duct every single time because that would be a more accurate measurement. But many times, it's just not accessible or it's a real pain in the butt, and maybe it's just not worth it. So we might want to decide to hook up at a grill or at a register. Now, it's a very simple measurement to do. Let's talk about delta T and target evaporator exit temperature. You have two psychrometers. One set at the return and one set at the supply. The jobbing psychrometers have switches on the back that are labeled return and supply, and you have a color indicator, red or blue, indicating which one you're at. That way the app knows exactly where to put the measurement based on how you set these up. They're both interchangeable. They don't have to be on one side. So if I'm going to go in duct, I could probably use this for that. There's no hose. All right, let's just go register grill. So you can hook it up somewhere with a strong magnet there into the return airflow, and then out the supply with the magnet there. And with two of those things, you are getting your dry bulb, your wet bulb, your humidities, your dew point, your enthalpy, and your delta T all in the palm of your hand, and it didn't take more than a couple seconds. Also, what the app does is that it performs a target evaporator exit temperature test, which means it looks at the humidity and the temperature on the return side, and it calculates what the supply air is supposed to be on the outside. So we can look at the air going across the evap coil in two different ways. We can look at a straight delta T and just looking for a differential, and we can look at what a target is supposed to be and then compare it to the actual value there. Simple. Now, if you had a situation where you weren't going in duct or there just wasn't metal, so the magnet wouldn't be effective, you can slide the magnet up and there's a hook on the back that you can clip it onto a fin of a register as you put it inside, and it just stays there. Okay? Now, it's probably what we're going to do for something like this. Usually it's something that's on a roof. But yes, so any way that a tool can help you take a high-quality measurement is valuable to you to make your job a little bit easier and a little bit faster. Okay? So those are delta T, two quick checks you can take to help check the performance of your airflow. Another way that we can check performance of our airflow is measuring static pressures. Okay? Now, sometimes static pressures can be like a hassle, to measure. Got to pull out a whole spaghetti ball of tubes, and put them in the right location. But static pressures are very, very useful to take because they measure the amount of restriction to the airflow in your ductwork and across your equipment. So there's a couple different tests that we can take when we're measuring static pressures. We can check pressure across a filter drop, pressure on one side, pressure on the other side. Although typically, we can see when a filter is dirty, right? But we could also do that. There's some other usefulness in measuring the pressure drop across your evap coil. But one of the most common ones is a target external static pressure. And what's useful about a target external static pressure measurement is that the manufacturer sets a value at which that equipment should have. So typically, they set the value at 0.5 inches of water column. Okay? Now, to take a total external static pressure test, it's important to know where to hook up the measurements. So in this particular piece of equipment, we got a furnace and a air conditioning vertical, right? All in one. Now, what we don't do to take a total external static pressure measurement is we don't include the heat exchanger, the blower, and the evap coil. That's not how you properly take a total external static pressure. What the manufacturer specifies is what is the pressure differential before and after the blower and the heat exchanger. That's it. That's what they specify as total external static pressure. So you would have two manometers transmitting to the screen in the palm of your hand, a P1 value and a P2 value. And it looks like, if you guys want to help me out here a bit, what's behind this thing right here? Blower? Perfect. Then we would want to insert one of these probes before the blower. Okay? There's not a hole here handy, so I'll just leave it like this for now. And then after the heat exchanger, which is probably right here. Okay, but before the coil, right? So we would have a hole, we'd put this in there, and we'd be taking P1 and P2 values. Now, something useful to know. Many traditional dual-port manometers have one sensor in there, which is a dual pressure sensor, which means it can measure the difference between two different pressure points, but it doesn't show you what just one is or the other one is unless you pull out one of the tubes and you have one tube like at ambient and the other one inside measuring something. Okay? So the convenience of having two single-port manometers that function as one single-port manometer or dual-port manometer is that you get to see what your P1 value is before you get to the equipment, what your P2 value is after you get the equipment, and what the difference is. So in this scenario here, if the manufacturer is recommending 0.5 inches of water column, we're at 0.95. That's nearly double what it's supposed to be. Okay? So in an ideal world, we would want to see, if it's supposed to be 0.5, we would want to see 0.25 here and 0.25 here, right? On the return side and on the supply side, both 0.25 will give us our 0.5. But we know we're at 0.95. Now, if I only had that information and not this on top, all that tells me is that there's an issue with restriction in the airflow, but it doesn't give me any indication on where to look for that issue. Now, the fact that I can see both P1 and P2, I can see, well, on the return side, I'm at 0.65. It's kind of high. On the supply side, 0.3, that's not too bad. So I know now, as a technician, I probably am not going to use too much time searching for issues on the supply side, but I'm going to focus my efforts on the return side. So being able to see individually what the pressures are on both sides will help you as a technician save time by focusing your efforts in the areas where you're going to find where the restrictions are. So it's very, very useful to be able to see that differentiation. And the fact that make your job a little bit easier too, you don't have to play with a bunch of really long 6-foot hoses, and hopefully you can get them right to where they're supposed to go. You could have short hoses that come with static pressure probes, insert directly into the duct. Now, going back to accurate readings. Does it matter which way we insert this probe into the duct? Absolutely, right? So, one thing is this static pressure probe has a magnet built in right here. So when you stick it into the ductwork, it holds there, hands-free. And on the part that's external, there's a red arrow. And that red arrow helps us orientate the tip in the correct direction in the ductwork, which is parallel to the airflow. Okay? You want the air, in order for the manometer to take an accurate static pressure reading, there are holes on the side of a static pressure probe. You want the airflow to be going over those holes, not directly into the holes, which is why you don't insert the probe perpendicular to the airflow, but parallel to the airflow. Now, if you're asking in or against airflow, it doesn't matter all that much, but against airflow is what most people recommend, and we'll just go with that. Okay? But the more important thing is that you are parallel to the airflow. Okay? That's a simple way to take a static pressure. Oh, and extremely important, before you enter it into the ductwork, what should you do? Zero it, right? And with the job link probes, it's pretty simple. Once you power it on, you just tap the power button once, it blinks blue, and that's zeroed it for you. So it's ready to be inserted into the ductwork, and switch on the back P1 and P2 so the app knows where to map the value automatically into your application. So going back to airflow, these measurements are very simple and don't take a lot of time to do, but they deliver us a lot of information and understanding of how the airflow is working. And when it comes to system troubleshooting, we want to be able to take good measurements fast. We don't want to spend a lot of time trying to find the problem, understanding the system. However we can do it faster, better, and accurate is going to help you do your jobs better and have a happy customer and generate more revenue. And finally, with static pressure readings, you could also use them to convert into CFM by looking at a manufacturer fan table and finding out what your CFM value is for that if you needed to do so. So back to our role play scenario, airflow, or the air wasn't coming out as cold as it should. We confirmed it quickly with a delta T test here and with a target evaporator exit temperature here. And we found a good amount of restriction here on the return side. So we replaced the filter and did some stuff there to help improve things on the return side. And we did that, and now since our probes are already hooked up and transferring the measurements, we see that we've improved it, but we haven't fixed the problem yet. The air's still not coming out as cold as it should be. So now, in this case, we're probably going to have to start measuring some pressures and some temperatures at the outdoor unit. So let's move on to that. Let's talk a little bit about refrigerant charge. So in essence, the main way that we measure refrigerant charge is, we all know, subcooling and superheat, right? Based on the metering device that we have, determines which measurement tells us more about the refrigerant charge. But the reason that we're taking pressures on a system is to get saturation temperatures. And then saturation temperatures get compared to pipe temperatures to give us those subcooling and those superheat values. Now, when we're talking about location and timing of pressure measurements, location, we don't have too many options. We have service ports. And that's pretty much going to dictate where we measure high side pressure, where we measure low side pressure. However, if we're talking about accuracy, it's nice to have a pressure sensor that has a built-in barometer to adjust to different elevations. Now, that might not be useful to everybody, but for many that have to go to different elevations as part of their job, it's just always nice to know that your pressure reading is always going to be accurate based on the elevation that you're in, and that your probes are meant to be rain resistant, water resistant, and be able to work in all the weathers that you see out in the field. So accurate pressure readings. I want to spend a little bit of time talking about measuring temperature on a pipe. Now it seems a relatively simple thing to do, but there's a lot of complications that can cause a not so accurate measurement. So on your typical surface plate thermocouple, you might run into some issues measuring temperature of a pipe. Now, when we're trying to calculate superheat or subcooling, let's make a distinction here. What are you trying to know? Are you trying to know the temperature of the refrigerant inside of the pipe, or are you trying to get the surface temperature of the pipe? What are you trying to measure? You're trying to measure the temperature of the refrigerant inside of the pipe. Exactly. And in an ideal situation where you had a very clean copper pipe with no debris, and there were no ambient conditions around it that could affect or change the temperature of that pipe from the temperature on the inside, then you're good to go with the surface plated pipe clamp to get that measurement. In the real world, you guys see those conditions? No. Right over here. On demo units. That's why I love demo units. This makes the job a whole lot easier, right? In the real world, on these pipes, there's going to be a lot of stuff that's going to affect the temperature on the surface of that pipe. Gunk from insulation that's left behind, corrosion, if the pipe is wet, if you're taking a measurement in direct sunlight and it's hitting the plate of your thermocouple, all that's going to adversely affect your temperature measurement and not give you the most accurate temperature reading. And that's important because that could be the difference between calculating 8 superheat versus, 8 subcooling versus maybe 4 or 5, which is a big deal. Okay? When we're trying to give the customer the best information for them to make the correct decision for them and their home, we got to give them the most accurate data for them to do that. So that's why Fieldpiece has invented and patented the rapid rail sensor technology to help overcome all of those problems and give you guys a fast, accurate temperature reading in the field. So I just want to talk to you about how do you use that. So when you open up a rapid rail sensor, you'll see 2 sensor strips here. Now I'm going to turn this one on, and you'll get a flashing green light. Now, when the clamp is closed and those 2 thermal strips touch each other, you get a single beep, and the temperature circuit is closed, and it's measuring temperature. Right now, it's measuring temperature. When I open it up, you get a double beep, and you get a flashing yellow light, indicating that it's an open circuit now. So it's not measuring any temperature. So why is that useful? Well, what a rapid rail sensor does is that it uses the conductive properties of a copper pipe to close the thermocouple circuit, and the pipe becomes part of the sensor. So no longer is it a sensor on top of a pipe measuring surface temperature. The pipe becomes part of the thermal sensor here. So you get an accurate reading instantly when you're measuring a pipe temperature. Now, what this requires is at least 1 point of connection onto a pipe. Now, what if I put it onto a piece of a pipe where there's just a lot of crap on there and there's not good contact with the copper? Both of you are correct, right? So I put it onto a pipe and I get a double beep and it's yellow. Crap. Now, the first thought is, well, this clamp sucks because I don't get a temperature reading. Okay? But what we don't realize sometimes is we don't want the reading in that location right now anyways, because it's not going to be as an accurate representation of what's going on in the pipe because of insulation, dirt, debris, whatever the case may be. So what you could do for a first resort, just kind of wiggle it around a bit, kind of like cut through that, and then as soon as you get like a contact with copper, you'll get your single beep, and you're getting measurements. Now, if that just doesn't seem to work, maybe you can move it a little bit to find a cleaner spot, or these also come with strips of like sandpaper that you can sand down a spot if you if you're so in love with the spot that you found, like you're going to a Dodger game and you just have that parking spot that you just got to have, if you need that spot on the pipe, there's a sandpaper there. You can clean it off and get a good connection on your pipe. And that ensures that you get an accurate reading every single time, so that when you're talking to your homeowner and you're telling them about their system, you're giving them the best data possible. Okay? And that might actually cause damage to your pipes after some time. But yeah, and what's actually like good about that is that since you only need a single point of contact, you can even measure temperature on an elbow or like on a bend if that's all you had access to, because all you need is a point of contact on the copper, and then it'll measure the temperature of that pipe.
What's the largest pipe that you can put this on?
This one will go up to 1 3/8 inches. Now for refrigeration applications, there's the large pipe clamp, also with the rapid rail sensor, that will open up to 4 1/8 inches. So, end of last year. End of last year. So for those in refrigeration, you got to work on larger pipes. There's a large version of the rapid rail sensor that will clamp onto those pipes. So you don't have to use Velcro straps or thermocouples or waiting for the temperature to stabilize because you've used your finger to put the bead onto there, so you've increased the temperature, and now you got to wait. No. Clamp it on, get a pipe temperature in a second.
All the wireless stuff, does it take batteries or do you charge it? How's that work?
AAA batteries. Typically, they're going to take two AAA batteries. Okay, so we're talking about quality measurements and how that relates into the benefits of wireless system troubleshooting. So we want to take accurate pressures and we want to take accurate temperatures in order to get good calculations, in order to give our customer the correct information that they need to make the right decision for them. So, refrigerant charge. Now, to wrap it up, in addition to the tools being able to transmit into the JobLink app, a lesser known feature that we could talk about more at the booth or just outside of this class is that the JobLink probes can also use the SMAN Manifold as the hub screen for the measurements. So if you have a manifold and you want to be able to monitor evaporator delta T on the screen of your manifold, you can wirelessly connect the psychrometers to it. If you want to be able to track your refrigerant weight from your scale, you could also view that on the screen of your manifold. And if you wanted to not have the typical wires that come with your pipe clamps, you can use either one of the JobLink small or large pipe clamps to work with your SMAN manifold. So you have two options to serve as a central hub for your wireless tools. But the point is so that you can be in multiple places at one time, and that helps you get the information you need faster, and it gives you a more accurate snapshot of the total performance of that system, all on either screen, either your app or on the screen of your manifold. So, wireless data connection, some of the benefits that help you in the field is a wireless range of 1,000 feet, line of sight. Now, let me just make this clear because there's going to be a lot of questions about that. There has been no change done to the JobLink probes. Any probe that was bought has this wireless range. Previously, we were very conservative in marketing what the wireless range of the JobLink probes were. We stayed at 350 feet, knowing that it went much farther than that. 350 feet at the time was fine because no other tool even came close to that. And then other tools got new versions and started marketing that same range. And so we thought, well, since we know that our tools go much farther than that, we might as well talk about that as well. So we did a bunch of extra testing to ensure our claims, and we tested competitors and everything all at the same time, which is why we're confident to say that the JobLink probes have a wireless range of 1,000 feet line of sight. Now, if you're within a building, maybe you have several hundred feet, maybe not 1,000. But it's still, by far, the best wireless range in the industry when it comes to wireless tools. And without good wireless range, these type of tools are just like paperweights if you can't get the measurement where you need it to come to. Okay? Wireless system troubleshooting also helps promote safety. You don't have to sit in uncomfortable or dangerous situations sometimes to get your measurements. In a very hot attic, in an extremely cold freezer, things like that. It helps keep you safer. Time savings, because you aren't walking back and forth across the job site. You have all your tools set up, and they're all being transmitted to you. And real-time diagnostic assistance as well. If you also had applications where you had to data log, the JobLink system also supports data logging. We could talk more about that later, of leaving your tools on site. You don't have to leave your phone or your tablet. Leave your tools on site. All the data gets stored into the tools. You come back, retrieve your tools, just upload the data onto your app, email it out as an Excel spreadsheet so you can look at later. And finally, incorporating wireless technology helps you grow your business. We talked about happy customers. A customer is happy when you deliver them accurate data and an accurate assessment of how their system is performing so they can make the best decision for them and for their comfort in their home. Using wireless technology helps increase your professionalism in front of the eyes of your customer. It separates you from Joe Blow Air from down the street because you have all of these high-tech advanced tools connected to the system, and in the palm of your hand and with PDF reports with your own company information on top, you are communicating to your customer clearly what the issues are, and that builds confidence from them to you, and it helps you close more business at the end of the day. Okay? And then another benefit is because you're taking high-quality measurements all around the system, you are optimizing the system right the first time, and you're reducing callbacks. How many of you love callbacks? Let me see all the hands. There we go. There's always one. There's always one. Nobody likes callbacks. So if you could have tools and technology that will help you get it right the first time, it's going to save you so much money in the long run, and you have happy customers. That's all I got for today. Any questions? Yes, sir.
The report thing, I've never used the report thing. That's like a monthly charge though, right?
No. Everything I've shown here today is free to use on the app. Connect your tools, all the tools at the same time, clamp meter, charge, air, weight, and then you can generate that measurements report right here with your company logo and all the measurements organized by their category. You can email that out. Now, if you had a paid subscription, you would have a different type of measurement report that would have some more information in it, and that data would be stored in the cloud for you and your customer list and your job list, so you can go back to it whenever you want to if you had to go back. But all this is free.
So you can still store the free thing in your email.
Absolutely. Put it into your work order management system, store it for your own records, whatever you want.
That the paid version, Fieldpiece, kind of explains what the measurements mean versus you explaining to your customer.
A little bit more, yep. And it also has like inspection checklists, photos and notes, equipment information, things like that. For you service managers out there, if you never heard of the live look-in feature, briefly what that means is you can have your technician out in the field using the JobLink system. Everything's hooked up. They got the measurements on their phone, but maybe they are less experienced or just can't figure out what the problem is. They can call their service manager or just a more experienced tech. That tech can pull up their JobLink app and view live what that technician is viewing in the field, so that when they're talking on the phone, they see the same numbers in real time, rather than having to talk about numbers back and forth. Okay? So that's another of the premium features if you have a subscription. to the JobLink app. $12 a month per user or $120 per year. Yep. Okay. Did you have a question from the chat? You're going to raise your hand?
I had a question. Somebody asked, is there a good method for knowing where to place static pressure probes so that you aren't in a high or low pressure spot?
Yes, there is. I'm talking to you, camera, because it came from the chat. Oh, so the question was, is there a good way to know where to put your static pressure probes so you're not in a high pressure or low pressure scenario? I'm going to honestly say that I don't know that answer specifically. You can reach out to either like Jim Bergman or someone with more knowledge of that, but I will also look that up. And if you send me an email to my email information here, I can give you more information on that as well. I'm just not going to make some stuff up.
Tony, the short answer is
Okay, short answer, perfect.
on long lengths of ducts, you want to stay away from bends, because any bend is turbulence.
Awesome.
So the short answer is in the center of the duct, don't go corners, don't go anything weird, on long, yeah, the longest stretches of duct you have. If you're
Okay.
with like flex duct, good luck. I don't.
Okay, so the answer they'll tell me right now, it's you want to find a long run of duct and try to avoid bends or pinches, around there. And typically, what, 4 to 6 feet on each side would be good.
Lengths is the actual.
Okay, 4 to 6 duct lengths, and that will ensure that you get a good measurement. Thank you, appreciate that. Yes, sir, in the back. Mr. Loves Callbacks. What's up?
Like on some of the stuff that we work on at Panama City, the condenser and stuff like that is all brick.
Yep.
And the air handler or whatever we're working on is several floors down, sometimes on the second floor, on a 23-story building.
Okay.
You said that those will store information that you can load back up later.
Yes. So that's a great question. So yeah, if we're talking about 23 feet, that's going to be pretty hard to get through, right? I mean, yeah, 23 stories, that's pretty hard to get through. So what you can do with the application is you'll see that there's this button that says freeze. Okay? So each of these containers that for like refrigerant charge or airflow or for whatever, you're going to see a button that says freeze. So if you're in a location where you know it's just crazy long and it's not going to work, go to one side of the system first, take those measurements, and press the freeze button. That'll lock those readings in there so that you can go to the other part of your system, do the same thing, lock them in there, and generate the report with your measurements. So it's just as simple as pressing the freeze button. Then it holds them in there. It's a good question. Thank you. Any other chat questions? Any other questions here? Yep, one more.
Another one, on your clamps, even that great big one,
Uh-huh.
some of the stuff we work on is water source.
Okay.
And in our reports, we have to give water source in and out.
Yep.
Those probes take that temperature.
Let me ask you this. Are we talking about PVC piping or are we talking about some type of copper?
It'll be like galvanized, most of the time it's galvanized.
Okay.
Very rarely do they put PVC on a system that's going to have that kind of pressure going through it.
Okay, so if
With that much temperature going through it, PVC will bust.
so if the pipe has conductive properties to it, then yes, you can use that to measure the pressure or the temperature of the pipe. Now, we don't have a solution that goes inside of one of those to measure like inside, but if the pipe is conductive, then the rapid rail will work for that.
They just measure the liquid temperature itself inside the pipe, right?
Well, it's going to be measuring the surface temperature of that pipe, and the assumption is that the surface temperature of that pipe is the temperature of the water. Now, if there's reason to believe that it's not, then it's still just measuring the surface temperature of that pipe because nothing's going inside of the pipe to measure the water. Right. All right. Well, thank you, everybody. If you have any questions or comments, you can reach out to me or just talk to me throughout the symposium. Thanks.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.